Greetings, everyone, and welcome back to the YouTube channel, An American Professor. In this video, before we continue onward with our reinforcement learning project, Tic-Tac-Toe, first I need to cover two important modules in Python, that is NumPy, which I'm going to cover in this lecture, and I'm going to cover matplotlib for plotting in the next lecture. So if NumPy is the fundamental package for scientific computing with Python. It's used by millions of engineers and scientists globally. Its most versatile object is the n-dimensional array, which I cover today extensively, and it enables working with a wide variety of numerical data in many shapes and sizes. To learn more, visit numpy.org or read the documentation, right as here in these links. Next, why NumPy? Why should we care about NumPy? NumPy code is performant. That means it runs very fast. NumPy package also has many useful functions for scientific or engineering applications. The syntax is intuitive or operates at a high level, just like the Python language itself. NumPy is open source and free to use, just like Python programming language. After learning NumPy, one could get a job working in data science and eventually work towards a machine learning job after even more knowledge is obtained, but NumPy is an important first stepping stone. The Harvard Business Review has described data science as the sexiest job of the 21st century in one of their recent reports. So learning Python and NumPy will pay you back down the road. Numpy Basics, the n-dimensional array. The ND array is the fundamental object of NumPy. It is the workhorse for vector, matrix, and tensor operations in Python, useful for data science and other tasks such as machine learning, reinforcement learning, etc. Math operations on ND arrays are faster than lists or other container types we mentioned earlier in this lecture series. It's very easy, as you'll see on the methods of using ND arrays, NumPy arrays, to compute summary statistics like means or variances on different arrays, or aggregator functions such as max, min, etc., with very little coding required. The methods are already there and ready for you to use. Furthermore, NumPy offers many more specialized numerical functions useful to engineers. Some more information on NumPy arrays. NumPy arrays can represent 1D vectors, 2D matrices, or any other higher dimensional tensor. Every element of an array must be of the same data type. Arrays differ from lists, and that lists can be inhomogeneous, that is, have different data types for different elements. Like you could have a list with bools and integers, but arrays must be all integers or all floats, for example. NumPy will fit together nicely with matplotlib when we cover plotting, because what we'll be plotting is actually data contained in the NumPy arrays. In future lectures, you'll understand this more. So how we import it is we say import NumPy as NP. And most Python distributions, or when you install any current version of Python, you'll have this module already installed. So to get NumPy, we call it as import NumPy as NP. And all the functions and objects we can just grab directly by using this dot notation, which you'll see shortly from np dot, etc. So how do we create an array? Let's create our first array and call it array underscore 1D. Let's create a 1D array with the elements 111. It's like you put a list containing 111 inside of the array constructor. That's a good way to think about this. Doing so will create a 1D array. Soon you'll see the notation for creating 2D and higher order arrays, whatever suits your needs. Next, let's see some of the attributes and methods available to use from this array. As you can see, there's tons of attributes and methods. Some of these you may recognize by name, like argmax, all, any, comprod, cumsum, data, dtype, mean, max, etc. And in these next few lectures, we'll cover some of these as we review more about NumPy. And the same thing, there's just a lot of attributes and methods. So these attributes and methods were found by calling dir on our 1D array object we already defined. To review what that is, go back. It's defined a 1D vector with 3 elements, 1, 1, 1. Some of these attributes in terms of programming are used much more frequently than other ones. At least I find that to be the case. For example, dot shape, dot reshape, dot argmax, dot argmin. Those mean like find what index in the array has the maximum or minimum, return those corresponding indices. And you know what these summary statistics are, like dot max would find what's the maximum element of the array, find the mean of the array, etc. They're all commonly used attributes, and it's easy to infer what they do by looking at their names. Some attributes of arrays that are useful for understanding the memory layout is dot shape. It returns a tuple of array dimensions. So for our 1D array, it's shape. We could call dot shape on it. We could call dot indim, dot size. Dot size is the number of elements in the array. So for our 1D array, it would return 3. Dot shape, it would return 1. Indim, the number of array dimensions. Indim would return 1. Dot shape should return 3 by nothing. And so on. You can experiment with these now that you're getting familiar with what's available in NumPy. And here I've already done the hard work for you. So you can see dot shape would return 3 comma nothing tuple because we're dealing with a 1D array. And dot shape returns a tuple. So here you can see a singleton tuple. Dot indim is only 1 dimension. The in bytes is 24. So we had 3 integers in there. So each integer is of 8 bytes. And so on. Dot size is 3. That's it for this video. We'll probably do a 3-part series on NumPy and then a 3-part series on Python to make sure these lessons and lectures aren't too long, but you're learning enough in each lecture to stimulate your curiosity. All right, signing off. Don't forget to hit that like and subscribe button. Have a blessed day. Bye-bye.